flowering universe theory. I believe this is take 7 or 8. I guess I have to check. I saw some Big Bang videos, and I'm sure the doctor, multiple doctor, anyway, he had a balloon, and he blew it up, and he showed, the known universe, like all the stars, all the galaxies, our galaxy, all that stuff. And then he kind of let the air out, and he shrank it. Let's start with that. All right. So imagine the balloon. It's shrunk. Okay. Now let's compact all the universes, all matter, everything we know, speeding through the universe right now, into the space of like a bowling ball, which staggers the imagination. Now imagine just the gravitational force of it alone is starting to tear it apart. Now when these pieces start to try to come back together, they actually produce an astounding force. Just by separating and coming back together is a tremendous amount of energy. And if this thing starts fracturing, and a lot of pieces start doing that, fracturing and slamming back into our bowling ball, it's going to continue fracturing, and it's going to continue doing that until there's just so much force. Even though these pieces want to stay together, they're just blown apart, and sped through space, and they still have the same force, and they want to stay together. But what that does is it kind of because they're speeding in opposite directions, they're not going to come together. The force has already been overwhelmed. They're not going to emit extra force. So it starts affecting other pieces around it that are going in the general same direction. And that's why you have a reality or a universal old picture that has, different, it's not uniform. There's different pockets of cold, hot, and just matter. And you kind of speed up the acceleration for 13 billion years, and that's what you have today. And we have a little shard of what's left over. The very cause of the Big Bang is at the center of our galaxy, and it's been collecting a lot of things over a 13 billion years period, and it's still accelerating, and it's still going, and it's still collecting. But some of the closer pieces, a brilliant female scientist, I really should look up her name, showed them coming together, and it's a little weird dance that kind of looks like what you would think of an atom when you see the atom picture, and I guess the electrons circulating. I don't know. I'm a philosopher. I study everything. So that's kind of everything in a nutshell. And how long it took to collect all that matter, and why it would collect that matter is probably because there's matter to begin with. Matter clumps together and stuff like that. But just the vastness of the universe that we've been traveling for 13 billion years, and we're accelerating, we're still going. It staggers the imagination how big space actually is, because if you were going to grid it, our 13 billion years of movement would be not even one square. It would just be a dot, like you hadn't even moved. I guess. I don't know. But we haven't slammed into anything else. I know some galaxies have collapsed on each other because the black holes in them are combining. But I don't know if we've... that's a good question for science. Has anything passed through our little balloon expansion? Have we seen any other matter besides the matter we know exists in the universe? That would be a good question. And how can you monitor, and how would you know? probably speed, direction. But then if it slammed into something like a galaxy or a planet, you may never know, or I don't know. But if it was an explosion like ours, there should be a lot of it. But because there isn't, I guess you might assume this is the first Big Bang. But it definitely, even if it is the first, it definitely won't be the last. Thanks for your time and for listening to my rambling.